So hello everyone, thank you for having me. My name is Natalia Venditto, and 20 years ago I was a designer. I actually started to be a buildings architect for a while, but then I got acquainted with graphic design and computer graphics in general and loved it, and my path changed. And then the internet appeared and I became a web designer and finally transitioned to a web developer, and now I work as a solutions architect, but I am super obsessed with the universe, so who knows where the future will take me. Front-end architects need to have a very broad overview of the system they work at and the concerns involved, from the very, very infrastructure to the important integration patterns, the integrations of code, of the code base, the front-end setup, the technologies involved, the best way to put all the pieces together. They need to have knowledge on browser support and its constraints and strategies to overcome those constraints. They need to know about standards and specifications, about protocols, about APIs, about E2E testing. They need to be very knowledgeable on security, on authentication, on content policies, on headers, on how to prevent exploits, on how to better store data on the client side. And needless to say, they need to know how to troubleshoot, debug, how to access sources, and how to make sure runtime performance is within budget and how to preserve an impeccable UX experience. And while they have their mind on all that, they also need to keep up with the new trends that appear every day. And those trends are in the form of patterns, in the form of frameworks, in the form of architecture. And there is an architecture trend in our industry that a lot of people love a lot, but I recommend you don't follow. Hype-driven development. And you know what I'm talking about. Something new comes out and everyone wants to have that on their stack. But we need to be cautious. We need to really understand the pros and the cons before we jump on the wagon. One topic that is very, very hot right now are micro frontends. You probably have heard this word around a lot recently, and you're wondering if it's the right solution for you, for your project. And I don't have that answer. And simply, I don't have it because whether a type of architecture serves or not the purpose depends on the problem and the use case. But let's try to shed some light together. Basically, we all know this is more or less an accurate representation of the layers of any application, particularly large applications, those that have a bunch of stakeholders behind it and more than one cross-functional team working on it. Because if we are talking about small applications or medium-sized applications even, especially the ones developed and maintained by a single developer, you can go directly to the end of this talk. There are very, very few reasons why you may need micro frontends in that scenario. But anyway, back to our layer cake. When the code base and infrastructure that represented becomes too massive, we usually know it by the name of monoliths. And a lot of people are super quick to judge monoliths, but they're not always a bad guy, I promise you. There are advantages. And focusing on the front-end code only now, having a single build for your code gives you the opportunity to keep your dependencies in check and implement techniques for code optimization and performance, like leveraging to the max this possibility of sharing resources and assets, and mechanisms like code splitting and tree shaking. And there are obviously other advantages. For example, at the time of implementing an E2E testing strategy, what we see here is what we used to do until HTTP 2 was out, which was aggregating all front-end code together in a large CSS file and a large JavaScript file to minimize the number of requests. But now, with modularization and the use of chunks and the use of async loading, we can definitely get very, very good results and keep our code base consolidated. And we don't need to do any other optimizations. It's really good to have these possibilities at build time. We can even go further, and we can package common code into libraries and consume it from a public registry like npm. Like, for example, say you can package all your style abstracts together as an independent package, all your JavaScript helper functions that you may not want to write over and over. You just abstract them and put them in a single file, and then you can reutilize that code everywhere. Of course, when you have a very aggressive abstraction strategy, and when you consume from NPM very heavily, which everyone does, you will want to have a very well-designed code splitting and tree shaking strategy. Tree shaking is essential to prevent code duplication. And even since Webpack 4, we have the ability to flag our modules when they are pure, and we can safely prune them. And we can do that by using the side effects property. So let's take a look at this graphic here and imagine this scenario that a lot of people, especially in enterprise or at enterprise scale development, are very familiar with. Imagine we're a team, and it's our sprint, and we have this page or this view with many components on it and services and stuff behind it, and only a few of these entities are going to be worked on this sprint. So maybe number one is a full feature, and a new feature, by the way, and 2 needs to have the JavaScript a little bit extended or refactored, and number 3 is, I don't know, maybe new configurations coming from the backend, right? Typically, how we do this is, if we are working with a Git flow, is we will branch out from our default branch, be it develop or main or whatever you call it. And very likely, if it's a large project, you will have teams work on each feature, probably pairs of back and front end, maybe a larger team. And then you will very likely open a release branch from the default. And when everything is in, you will deploy it to the production environment. The problem with these dynamics is that from a technical perspective, every release triggers a new version. So the whole system is needs to be rebuilt and redeployed just because you made a few changes. So the whole monolith gets rebuilt. And I think that one of the issues that teams were trying to solve or were trying to find a solution for when breaking apart the code in this micro, whatever it is, front ends or services, was to solve the problem of the to provide the opportunity to have independent release cycles for features. So they needed to find a way to deploy independently. You have a feature connected to a business domain, and this feature is being constantly maintained, right? As opposed to another one that is hardly ever maintained, or even no longer maintained, no longer supported. But then again, when you release your dynamic capability, you have to release the whole code base. So in the backend, they broke apart by feature, which gave birth to the microservices architecture. And just like monoliths, the microservices have pros and cons, but it really solves that problem that we were talking about before, the deployability issue. Although it needs a good team setup, and it needs also dedicated processes to make it work, and it needs also a different kind of mindset to make it work. So for it to work, instead of having a business, let's say, area or capability behind the whole set, you should respect these principles. Every independent team working on a feature is basically under the umbrella of one business capability, or mapping to one single business capability. So there should be an independent team owning the feature and making their own architecture and processes choices. A small part should be able to fail safely and silently. And basically, when the backend is decoupled, the most organic solution for the front end is to also accompany the split. right? And this is when it makes sense to have a microservices/micro frontends architecture. Now, micro frontends can be implemented in different ways, and I think the key differentiator is the level of encapsulation required. When the level of encapsulation required is very high, integration is safer from a security standpoint, but it is a lot less performant. Since you cannot share anything, you cannot share cache styles, fonts, and other dependencies, there is less opportunity to reutilize code. We see here some of the techniques, like hyperlinks or web components. Each technique provides a different level of encapsulation, and it's the result of a different type of containerization strategy. So for composition, you will need some sort of container to integrate all your micro frontends. They are a container in itself, but you also need to put them all together. So what kind of container that is will very much depend on the pattern and technique you use. It will very much depend on how your micro frontends coexist in a platform. If they are loaded in one single page, you probably will need something like a host or app shell to load them. We can think of this as the host, the runtime that will expose shared and vendor dependencies, as well as the APIs for communication between the parts to happen, and also for state management, for example. Apart from having a team that is in charge then of every micro frontend and mapping to a business capability, you need to have another team that is responsible for this large container, for this application shell. This team, again, is the one that coordinates, the one that makes possible the full integration. Now, all these scenarios that we were discussing, all these micro frontends were requested and loaded from a single origin. So basically, you still had the chance to integrate them in one unique build system if you wanted and run static analysis. But if a micro application was not hosted in the same context, it was somewhere else in a different origin. Imagine the scenario where a part of your application is developed by a third-party team, deployed independently in a completely different domain, but still needs to be integrated. You could do that, of course. There are already some methods existing for many decades, custom and standard, but there was no way you could optimize the front end. You could optimize the shared dependencies and shared assets. But now we have Module Federation. This is what I wanted to talk to you about in essence. And it will evidently change the game when it comes to micro frontends and the ability to deploy independently with mixed languages, maybe with different technologies in the same page or in the same context. Before Module Federation, you could not perform any type of analysis for optimization and shared dependencies at runtime. You could do it at build time, but not at runtime, because if you were using Webpack, as a dependency graph manager needs to know all the dependencies before it starts running, right? And now with Module Federation, we can finally do this at runtime and with remote applications. So let's go back to this example we've seen before. Module Federation assigns roles to runtimes. So you have remote scopes and you have a host scope, which defines the first Webpack runtime to be initialized. I want to stress, and I'm going to say it again during the presentation, that the roles of host and remote are interchangeable. What really matters, or what really makes a host at one time, is that it runs the first. In this example, each application is bundled independently with a certain configuration and hosted on a different origin or domain than the host. So we will need to make sure to configure a few things. We can see here the Webpack configuration. Let's start by the host. Obviously, we need to be on Webpack 5. And we need to require the plugin. And what's important here is that we need to give a scope name to our remotes. We can alias them in the remotes declaration, but remember that this is a JavaScript variable, and JavaScript variables have some naming conventions that apply. And here in the step 1, we can see we have the remote one declared as a remote. That's a global name of the remote, basically. So we can access it as window.remote1. And it's very important that the scope name matches the one in the remote configuration. We can also declare what dependencies we want to share between the host and the remote. Now, share components have a number of advanced options, like singleton, required version, strict version, share scope. Obviously, the more you configure, the more you constrain or limit, the more the chance that there's not going to be compatibility between what's in the share scope and what your remote needs. So you need to be careful with that. Or maybe that idea of independence of the team, it's a bit more complex than imagine, because there has to be still some sort of governance to what you're going to do in your project. Now let's go and configure the remote. The first very important definition is the public path, because otherwise the files will be resolved from the root of the host. If we pay attention to the exposes property, the module is the public name, and the remote one, that module.js, is the internal request. The file name remote entry that we see there is not the bundle itself, it's the loader. So the loading script that allows us to access the Webpack runtime of this remote package from a different origin. This is a representation of how federated modules work then. If we have a remote container and the host, the only difference between one and another, again, or what makes one the host and the other the remote, will be which one is loading first. So in this diagram, you can think of each one interchangeably. The share scope is basically the object where the provided modules live with their definitions. So containers, like either the host and the remote, they run a version check before loading from the share scope. They also validate parameters like we mentioned before, strict, singleton, or the version number. If a share module is in the share scope, coming from the host or the initial runtime, and versions are satisfied, it is the one used. The remote won't require its own dependency. If it's not available or the version is different, the remote falls back to loading its own dependency. And once you expose your module, you can dynamically load it to your app like you load your internal modules. Like, for example, if we are coding in React and we want to load the exposed module that we have exposed in our remote one into another application, we just lazy load it, and then we can use, for example, suspense in the context of the template. In Angular, you would also just import it to your module or to your routes, like any other lazy loaded module, from within the application. I think it's the same with Vue. I am not sure, but there is another talk in this conference that you can take a look at to see how it works in Vue. But in the context of frameworks, it's quite simple. Although there are some more complex use cases that would merit a custom loader, in general, it works with the regular loader of the framework. It gets more complex when you are on a vanilla JavaScript application. Then you will definitely need to write a custom loader or use whatever component or module loader mechanism you have in place. So we will see this in the demo in a little while. You probably also want a mechanism to either manually register, but manually is not so efficient, but to dynamically discover remote modules. And you want to probably have an API in the middle and some logic to update the remotes in your Webpack host configuration, especially for very large projects. So everything I said, I think it sounds great, right? And it opens a world of possibilities. And there are so many opportunities with Micro Frontends, and particularly with Module Federation. However, please also remember that the most important thing is the user. So it's the user experience. Frontend is built for the user and not for us as developers. The most important thing is that we preserve a great user experience, no matter where from or and how the frontend is composed. So the biggest challenge when we use this architecture pattern is to ensure that there is consistency, that everything is seamlessly stitched together, and that we cannot, come across some incompatibilities between modules or things that not look quite right. And we achieve that through orchestration. And by orchestration, I mean routing handling, I mean consistent styles and behavior, I mean thinking how you will sync browser history and how you will manage state from a unique source of truth, and also how you will communicate between all those micro parts. Because the idea of having independent teams deciding their stack and deploying on their own schedule sounds super appealing and almost perfect. There is no vendor lockdown, no migrating a whole monolith if a framework gets obsolete. But you have to make sure that the problems that you are solving are not smaller than the ones you are introducing. Because every layer of abstraction you combine makes it more difficult to achieve great results. We know, for example, every framework has different opinions on how you should implement state. That could be a very difficult problem to solve if you have 5 different frameworks. One mechanism we could use to simplify communication between components and even have some ephemeral state handling is an event-based publication and subscription bus, leveraging client-side storage methods like cookies and local storage. You will have to be careful with CORS in that sense. And you can also trigger API calls to persist state server-side on events. So there are many lightweight libraries that help you with this, or you can also go ahead and dispatch events using window.postMessage method, which that works across many browsers. For the demo, we have this vanilla JavaScript application acting as a host, and it has a couple of external micro frontends. One is a federated module. It's a web component, an Angular standalone element, and the other one is a micro application loading in an iframe. And all of those are very, very valid mechanisms for integration, and we're going to see how we have them running. The prerequisites to make this setup work is that obviously we need to be on Webpack 5 everywhere. We need a Node, I think, version 12 or above. And for Angular applications, you will need to be on Angular 11. Notice that Webpack 5 is optional for the Angular CLI because it was released only in November, and there should be a period where maintainers have the time to catch up. And also, I am installing dependencies with Yarn because that allows us to force resolution of dependencies to Webpack 5. And I am also using Manfred Steyer's custom builder, so we can give support to Module Federation plugin when the CLI builds with Webpack configurations under the hood. Now I'm going to switch. So basically what I want to show you is I'm not going to build everything again because for the sake of brevity, let's say. But if you see, I have this Angular 11 application over here. It throws some, errors because of Webpack 5. And also I have over here, a couple of servers. This is my vanilla application, and this is the Angular web component or element. And what we are going to see right here is that we have on localhost, let me close this. On localhost 4202, we have the web component, the standalone web component. And also on 4200, we have this application loading a bunch of kittens that want to be astronauts. I think this demo from maybe if you follow me from other conferences or presentations. And finally, over here, I have it all put together. So this is a JavaScript application, or it's an HTML index, and we have an iframe, and we have this. Let me show you the sources over here. Here we have the iframe. Again, we see that it's coming from localhost 4200. This is pretty standard, nothing new. Everybody has put an application in an iframe one or twice in their lives. But what is really interesting to us in the context of this talk is this test element here, this web component over here. If you see, it has a script tag and it's calling this localhost 4202, which is precisely this one. And it's calling the remote entry. Now, if I go to the network tab and I reload, okay, I see that the JavaScript is executed, that's the local JavaScript file, and then it's calling this remote entry from 4202. And this remote entry, if we examine it a bit, what it's doing is, giving some definitions, defining the remote, and also giving us access to that runtime, to that scope, and validating or verifying what are the shared modules that we want to, use from both sides, that we want to share in the share scope. And this is what happens. There is all this check, all this access to that runtime, and then the decision of whether we use the share component from the share scope, from the host application, or we fall back to using whatever is in the remote because of an incompatibility issue or because it doesn't find the module in the share scope. And if we now go here, let me close this. Let's go to the code. And remember I said, if you are working on vanilla JavaScript, you're going to have to think of a way to load and execute these functions that come in this from this remote scope. If you are working entirely in a framework, you are able to dynamically import and use the mechanisms available in the framework. So this is a Lerna monorepo, and I have here the application, the vanilla JavaScript application. And what it's also doing is adding an event listener for this message that it knows is going to be posted from the components that are inside of the either web component or the iframe. So it's listening to that message, and if it matches the topic, we decided in this case cat loaded, it's going to send another message, like it's going to post another message over here to the iframe. And if we go to the, let's see, if we go over here to the Angular application that is here in 4200, we see that we also have a host listener listening for exactly the same event, so we can react to it. And what is going to happen is that when I load the page over here, we see that we have some images loaded, and the rest are being lazy loaded. So we can click over here, and this is going to scroll. And well, in this case, it loads 6 on the first time because of the threshold. But we can do another one, and then we can see that is, I don't know if this is visible because it's very low, but it's receiving the message, cat should be loaded, and then we are scrolling and loading more stuff. And the experience is very seamless. But it's not only about this, how seamless the experience is. What is really a benefit in this case? Just imagine, this is a very simple demonstration for you to understand how it works from different origins. But what is the real benefit is that if there were changes in this web component, if this team that manages or that is in charge of this component decided to release a new version, to do whatever, to change it completely, the team managing the host wouldn't even notice. They don't have to release their application because there are changes over here. Obviously, still, I think that a certain level of coordination is necessary, and that the idea of that teams are completely independent is a little bit of a utopia, because it's impossible to, I don't know, agree on a topic to subscribe to if there is no documentation, if there is no communication between teams. But in essence, this is the greatest benefit of Module Federation, that you can have a higher level of independence, in the deployability, a higher level of saying, okay, if this module for some reason doesn't work, it's not available, nothing happens to our system, but also the fact that you can share dependencies, that you can share assets. For example, if we go here again, sorry, to the test application, we see that the title is not styled, but over here we have the possibility of, leveraging the styles that are in place because we are on a web component, and then we have the luxury of leveraging common resources and the luxury of deciding if we want to request our own Angular application to be bootstrapped, or we're going to use the one that is available not only for this module, but for any Angular application that was on the origin, on the host, or any other that is coming from a different origin as well. So thank you very much. Please find me on Twitter. I'm Amphibia Creativa. You can reach out to me and we can talk further. We can talk more about Module Federation. We can talk more about Angular. We can talk more about Webpack or whatever web technologies topics. Thank you very much for listening, and enjoy the rest of the conference.